Welcome to my YouTube channel. In today's episode, I am going to design and analyze and documenting a small filling station using robot structure software. I hope you follow me to the end of this training. Let's switch on my robot. I select building. First, I create axis in X direction 3, 12, 15, and the Y direction 0, 3, 6. In numeric should be A, B, C. Now the next step, I define my stories to 5 and 1, 2 levels. Again, I check my story in Z direction. Let's look it perfect. Everything is now successfully completed. Then next step, I define my columns, steel columns. Now I define my beams. I want to divide these two members in two. The top beams I divide into 4. Now I again draw my diagonal members. I search my node. There is something wrong. If you see the top member beam is not divided. Again, I divide into 4. Now every node is showing. Again, I have my nodes. The truss is now completed. I want to see with color my members. The color is available in the corner of my computer. Next, I want to copy to the grade 2. The next operation, I want to just copy my trusses in grade 4 and grade 1. Now again I want to add beam. Now the beam is applied in my field station. I want to cut it in every node, all of my beams. Now it's the time to apply support. Apply the fixed support. Add cladding. Now I want to delete this because there's something wrong. I want to delete this beam. I want to draw to the node 6. Now it's the time to apply the main beam. This is the main beam. All the load is transferred to the main beam, and the main beam transferred to the column. The other beam is just secondary. I want to off my grade on levels. Oh, I'm applying load, self-weight, additional load, and snow load. I had 1 kilonewton dead load. Three kilonewton snow load. I run my analyze again to check. Everything is looking fine. Just as something is wrong, I will cut this member, delete this member, sorry, and draw to another node. I switch the color in my beam. You can see the load, the transmission on the transfer load, and you can see by the color. And you can see the load felt. Again, I want to switch off. Now I want to add some wind simulation. The wind velocity is 20 kilonewton per meter per second. or 20 kilopascal per meter per second, sorry. Now it's completed. You can see the load here in every direction. Now I want to take some picture, screen picture. Also time to generate load combination automatically, but I want to correct this SLS combination. The load combination is generated. I run my analyze. First, I check the reaction forces. You can see it here, but ULS, ultimate limit shape. You can see the vertical, horizontal, and moment also. Second thing, I check the internal force, moment, with value. You can see Fx in vertical forces, Fy, and Fsi. It's the shear force. The last, you can check the stress also if you want, on torsion. The last, I want to check the deformation. In SLS combination, if you see, we have a 21 millimeter deformation. That's not very big. You can see the result graphically also. Now the time to design my steel member. First we can check the column parameter. The first beam. The second is the column. I have already defined it to save the time. Now I want to apply in my structure. The deflection for columns is L by 400. The deflection for beam L by 250. It's a little bit conservative, but for training it's okay. You can apply according to your local code. Let's apply. Just I want to run my calculation. I'll just check my combination. First I will add my ULS, second SLS, the maximum SLS. The program automatically selected. Now if you see, everything is green. That means our design is correct. But something is yellow because we have a problem of cylinderness. You can see the result graphically also. You can save the calculation if you want, and add it in your design documentation. The next step, design the foundation. It's available here. Yes, I had create some parameter isolate foundation. Just I change all of parameter to isolate to save time. The process is same. You can watch my earlier YouTube. The thickness I want to have 0.9. Now I run my design. There is a problem with reinforcement because the size is small, 1 meter by 1 meter. If I increase, now it's yellow. It's not wrong, but if I increase the size of my foundation, it will be green. Here is the result. You can see. I can decrease also then to 0.6. Again, run my analyze. Again, we have some problem with the reinforcement, but just increase the size of the foundation to serve this. There is my result. Now it's green. Because the arrangement is not correct, I should add the parameter. If you see in the down, this is not correct. I should apply again the same parameter in my foundation. Isolate foundation. The geotechnical also I should manually check it, apply it again. Now it's ready. It's run. You can see the rebar in 3D. Again, I put my structure. You can see about both of foundation is now applied on my structure. If you want to, if you reduce the size, the result will be green, but it's not a mistake also. Now I want to save this documentation in my computer. That was all for today. I hope see you in the next episode. Bye.